Hello, and thank you for watching this video on graphing linear functions by the slope-intercept form. What I'm going to do in this video is I'm going to go over the graphing of lines, how to graph a line when the line is written in the slope-intercept form. So to do that, well, we need to know again what the y-intercept is. Well, first know what the slope-intercept form is, which is the following format: y is equal to mx plus b. Understand and identify the y-intercept, which is this number here, which is going to be located at the point 0 and whatever that number b is, and then use the slope of the line to create more points using the ratio of rise over the run. Now, I don't have a ruler, but I'm going to connect those 2 points, and that's the way that the line is going to be drawn. So I have enough points to draw the line, and connecting those points, I'll have the equation of my line. So let's look at the first example. So on this first example, again, the first thing I need to do is identify those two values, identify what the y-intercept is, and then identify what the slope of the line is. So the y-intercept is going to be this constant right here, which is located at 5. So a very easy way of identifying what the y-intercept is, let me write it as b is equal to 5. Is by replacing the x value with 0. The y-intercept again is occurring where x is equal to 0. So if I replace this value of x, this number right here, with 0, that's going to cancel out. And as a result, the only thing that's left over is going to be the 5. So that is our y-intercept. So 0, 5, which is located right there. Let me do it in orange, right there. So that is our y-intercept. Then what we're going to do now, we're now going to then use the slope. The slope is the number that is being multiplied, the coefficient of x, which in this case are mx plus b. As you see right here, y is equal to mx plus b. The m is equal to the number -1. Now, since the slope is the ratio of rise over run, I need to have this number over another value. And with whole numbers, that number that we use is always the number 1. So the value of m here, let me fix this up, is going to be that m isn't just equal to the number -1, but -1 over 1. So we have this ratio of rise over run. Now, with a negative rise, that indicates that we are moving downwards, and a positive run means we're moving to the right. So from this orange spot right here, so from that point there, to identify more points on my line, I'm simply going to move down 1 and over 1, and following that pattern, I can identify more points on my line. And then connecting those points, I can draw my line. Now, while the slope again tells me which direction to go, remember, again, all of these points are going to form a straight line. So I know that over here, there has to be a point over here that when I go down 1 and over 1, I'm going to land on the next point, which would in this case would be the orange one. So I know that there has to be a point right here, because from that point going down 1 and over 1, I'm going to stay again on a point on the line. So now simply connecting those points, let me use this color, connecting those points right there, I end up with my line, and that would represent this equation here. So this picture, let me get a bigger eraser. So with this picture right here represents that equation there. So let's see, let's move on to another example. So again, we want to identify the slope and the y-intercept. So we'll start with the y-intercept first. An easy way of seeing is with the, if I plug in a 0 right here for the x, then that means this becomes 0, and this again gets omitted. So our y-intercept is going to equal to -1. Because 0 minus -1 is going to equal to -1. So we end up only with that number there. So that means that our first point is going to be located at 0, -1. So let me put that in orange. 0, -1 is located there. Now, our slope of our line is equal to the number of -3. But since we need our slope to be a ratio written as a fraction, as one number divided over another, one number over another, this number is going to be written over 1. And again, that's going to be the trick for any whole number. If the number is not written as a fraction, we do this every single time, just so we can get those two numbers and we know what our rise and run is. So our rise, again, is a negative again, so it's going to go down, and our run is positive, so that's going to move to the right. So I'm using the red, I'm going to move in that direction. I'm going to go down 3 and to the right 1. So counting from the orange spots, so from this orange spot right there, I'm going to go down 1, 2, 3, and then over 1, and that'll be my second point. If I go down another 3, 1, 2, 3, I'm a little bit off the grid, so I'm guessing that it would be somewhere right there. If I measured correctly, it would be somewhere around there. Now, because this is supposed to create a straight line again, then I know that there has to be more points over here on this side. There has to be more points in this direction, that if I go down 3 and to the right 1, I'm going to land on where the next point should be. So if I go up 1, 2, 3 and go to the left 1, notice again I end up back in where I start off with. So if I do that and I go up 3, 1, 2, 3 and 1 to the left, notice that this point follows the same slope. That from here going down 1, 2, 3 and 1 to the right, I land again on that orange spot. So again, there has to be a point over here where if I go down 3 and over 1, I'm going to land there. So I just simply retrace my steps and go up 3 and 1 back. So all I've done right now to get these points right here is simply retrace my steps, since my slope has to be -3 over 1. And that's pretty simple to do, because this is supposed to create a straight line. And with more points, well, that makes it easy to connect the points and make my line as straight as possible. Now in the next example, we have our y-intercept as +2. That's this number right there. Having this number become 0, we'll eliminate that, and the only thing we'll be left with is 2. So we're putting our first point at 0, 2. And since our slope is equal to the number 2 over 5, which is already written as a fraction, we have a rise and a run already. We don't have to put this over 1. The top number of our fraction represents our rise, and because it's positive, that's going up. And the bottom number of our fraction represents our run, which is because it's positive, it's moving to the right. So from this point here, let me color this again in orange. From this orange point there, I'm simply going to rise and run 2 units, and 1, 2, 3, 4, 5. If I go up 2 units, I'm not going to have enough space to find where 5 is, and it's a little bit too far off. That's 1, 2, 3, 4, 5. I don't think I'm counting or spacing that dot right here an equal amount as it should. So what I'm going to do instead, I'm going to do this instead. I'm going to retrace my steps. I know there has to be a point over here that if I go up 2 and over 5, I'm going to land on that orange spot. So if I retrace my steps and go down 2 and then 1, 2, 3, 4, 5, again retrace my steps, there's going to be a point there that when I follow the slope, go up 2 and then 1, 2, 3, 4, 5, I land on a point on the line. So using those points, I can connect those points and see where my line looks like. And like you see, if I extend this line right here, I'm a little bit off. So I wasn't giving myself the right amount of space. I wasn't spacing it right. But that's okay. With that other point on the left of my y-intercept, that's enough points to identify what the line looks like. So let's look at the next example. In our next example, we have a y-intercept of 3. So that's 1, 2, 3 up. So that's, let me do that in orange. So that's that point right there. And our slope is equal to the number of -1 over 4. I know the negative sign is in the middle right there, but with a fraction, I usually like to put it on the top number. If you're more than welcome to put it on the bottom number, but it's just easier to put it on top. And with the top number being negative, that means my rise is going to be downwards. I have a negative rise, so a downward rise, and a positive run is to the right. So from the orange spot, I would move up 1, and then 1, 2, 3, 4. And just like the last example, down 1, and 1, 2, 3, 4. And just like the last example, I can continue moving down 1, but then moving 4 over. 1, 2, 3, 4. I'm not too sure if I'm spacing those correctly, so what I'm going to do is simply retrace my steps. I'm going to find a point that's on the left of this y-intercept. So when I go down 1 and over 4, I land on that orange space. So retracing my steps, going up 1, and then 1, 2, 3, 4 to the left gives me a point right there. So with those 3 points, I can connect them and draw my line. Now on the next example, notice that we do not have a y-intercept. So on this example here, y is equal to simply negative 4x, which means that we have a y-intercept of 0. We're adding 0 in this situation. So our y-intercept is going to equal to 0, which is located right here in the origin. So going up 4, and our slope being negative 4, because it's a whole number, I would write it as negative 4 over 1. We would simply go down 4 and then over 1. So 1, 2, 3, 4, and then over 1. And retracing my steps, I can go up 1, 2, 3, 4, and back 1, and it has this slope. So again, from left to right, I am going down 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And again, I have that rise over run of negative 4 over 1. And then connecting those, my line will look something like that. For number 8, notice that our equation is written backwards. Notice that normally it's y is equal to mx plus b. Notice that the term with the x is now in the back, and the b, the constant, is now in the front. So these two did a little switcheroo, where our y-intercept is going to be the number negative 3, which is located on the y-axis 3 units down, and our slope is going to be 5, and 5 over 1 again, because it's the whole number of 5, so I'm going to write it over 1. So our rise over run will go up 1, 2, 3, 4, 5 over 1. And I think those are the only points that fit. So just with those 2 points, that even with only 2 points, that's good enough to draw a straight line with. And then for number 9, again, you'll notice that the same thing occurred. These two things did a little switcheroo on us, and instead of writing the equation as y is equal to mx plus b, notice that this term is in the back and the b value is in the front. So our y-intercept is going to equal to 1, which is positive 1, so that's 1 unit above the y-axis, right here in orange. And our slope is equal to the fraction of negative 6 over 5. And again, I'm going to put the negative sign with the top number, so the negative sign right there. So with a negative 6 over 5, we're going to go down 6 and then over 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And just with those 2 points, I'm going to draw a straight line as straight as possible, and my line will look like that. Well, that concludes again this video. Hopefully this was helpful and was a good refresher on how to use the slope and the y-intercept to draw the graph of these linear functions. Again, thank you for watching and I hope you have a great day.